Good. Thank you. Thanks. I appreciate it. You remember that all the things we have been doing when we do configuration, when it comes to assigning IP addresses to computers, we do it statically or manually. And that is not sustainable in the real world. It is going to be difficult for you to be giving people addresses, IP addresses manually. So it is advisable you give IP addresses dynamically or automatically. That is why you see when people plug into your network, they don't do anything, they just get IP details. And when I say IP details, you see other information that are added to the IP addresses. So that is what this DHCP is all about. We want to have a network where people get all these details automatically. We don't need to do it manually. So this is another level for us. So DHCP version 4, what's our objective? We're going to talk about DHCP version 4 concepts in a small to medium-sized business network. We are going to learn how to configure a Cisco iOS DHCP version 4 server, meaning we are turning a Cisco router to a server. And we're also going to learn how to configure a DHCP version 4 clients. These are the objectives for the class. This is one of my favorite topics. Very easy to communicate, very easy to configure, and students don't have issues understanding this also. DHCP version 4 concepts. So under the DHCP version 4 concept, we're going to talk about DHCP server, and we're going to talk about clients. Because as long as you have server, you must always talk about clients. So the full meaning of DHCP is Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol. And the one we are talking about today is version 4. DHCP version 4. So what does it do? DHCP assign IPv4 addresses, take note of that, and other network configuration information dynamically. Because when you look at your computer, you don't just use only IP address. You also get subnet mask. You also get default gateway. You also get DNS address. These are details that you get. Let me show you on my computer. If I go to my command prompt now and issue IP config /all. I am using my network, a wireless network card. Look at all the details I am getting here. I don't talk about IPv6. I've showed you guys that one before. I was still going to talk about that on Friday. I got IP version 4 address from my DHCP server. I got subnet mask from my DHCP server. I got default gateway address from my DHCP server. DHCP server address, I also got it from my DHCP server. And the last one I want to point to is DNS server, also from my DHCP server. So when you tell a computer to obtain IP address automatically, which we always do, let me show you that one also from control panel. You enter your control panel, you go to network and internet, network and sharing center, change adapter settings. And let me use my network card, the LAN card, to show you. Right click, then you go to properties, then you come down to TCP IP version 4 and then select property. Here you see that there are two options for us to give this computer IP address. One is obtain an IP address automatically. The second one is use the following IP address. And when you come down, you also see another option down. Somebody is saying they cannot see the parts. Ali, can you see what I'm doing? Can you see my screen?
Yes, it's visible.
Can you see?
Yes, it is visible.
Okay, it is visible. Okay, good. Maybe it's from your own hand. Maybe you are using phone. Are you using phone? If you are using phone, probably it's going to be small for you. Okay. So obtain an IP address automatically. What you are basically telling this computer is go and look for a server somewhere, not just a server, a DHCP server, and get your IP address. But if you select the second option, that means you want to give the computer an IP address to use manually. And the same thing applies to DNS. When you say obtain your DNS automatically, we are still telling this computer, go and look for a DHCP server and get all your IP address details or IP details. If you say use the following DNS server address, it simply means we are giving this computer DNS address manually. But we don't want to do that. We don't want to do that. So let's learn the concept of DHCP. Then we'll now see how we can set it up. Okay, so we said DHCP will assign IPv4 addresses and other network configuration information dynamically. Because desktop clients, take note of that, like this my system now is a client, typically make up the bulk of network nodes. DHCP version 4 is an extremely useful and time-saving tool for network administrator. It will make your life easier. Because if you don't have that, every single person that comes to the network, they have to bring their laptop to you for you to configure it and put all the IP addresses statically. And that is going to be cumbersome for you. So what do we do? A dedicated DHCP server is scalable and relatively easy to manage. Take note of this. I'm going to say something on this. Please mute yourself if you are not asking me a question. There are people that used to distract us by not muting themselves. I just heard somebody's voice now coming from the platform. Okay. So a dedicated DHCP server is scalable and relatively easy to manage. So what do I mean by a dedicated DHCP version 4 server? I will talk about that. However, in a small branch or SOHO location, a Cisco router can be configured to provide DHCP version 4 services without the need for a dedicated server. There are some small organizations, small offices where you don't need a dedicated DHCP server. It could just be one small branch, 10, 15, 20, 30 users. Or SOHO simply means small office, home office for people that work from home. So Cisco router can do that for us. Not only Cisco router, so many routers can do this DHCP work for us. Cisco AI software support an optional full feature DHCP version 4. You're going to see when we configure that. The DHCP version 4 server dynamically assigns or leases an IPv4 address from a pool of addresses for a limited period of time, chosen by the server, or until the client no longer needs the address. Now, whenever you get an IP address, it is for a period of time. Let me show you. And that is based on the configuration that is configured on the DHCP server. From here, you can see lease obtained. This is when he got this address. And this is when this address is expected to expire. But if I like, I can configure my router and say, as you give these IP addresses to people, give them for 6 months, give them for 1 year, give them for 2 years. I'm the one to decide that. Clients list the information from the server for an administrative defined period. Administrator configure the DHCP version 4 server to set the list to timeout at different intervals. The list, take note of this also. The list is typically anywhere from 24 hours The list is typically anywhere from 24 hours to a week or more. When the lease expires, the client must ask for another address, although the client is typically reassigned the same address. So when the time that you've been given this IP address has expired, it's like I'm saying, okay, I'm going to give this IP address for 24 hours. After 24 hours, what happens? I can renew it for you. As a server, I can renew that address for you. So let's talk about the operation before we go to configuration and see it at work. DHCP version 4 operation. DHCP version 4 works in a client/server mode. What does that mean? Somebody is sitting down as a server, and then we are going to also have clients. What is the job of the server? Is to dish out IP addresses. What is the job of the client? Is to request for IP addresses or IP details. As long as you have server, there must be client. As long as you have clients, there must be server. When a client communicates with a DHCP version 4 server, a server assigns or leases an IPv4 address to that client. The client connects to the network with that lease IPv4 address until the lease expires. The client must contact the DHCP server periodically to extend the lease. This lease mechanism ensures that clients that move or power off the not keep address that they no longer need. Why are we listing these things to you and telling you that it's only for 24 hours, 48 hours? What if I give you the IP address for 1 year and you are no longer on the network? For some reason, you are holding my IP address to ransom. When the lease expires, the DHCP version 4 server returns the address to the pool where it can be reallocated as necessary. And we are going to say this. So how does a computer get an IP address? Look at the conversation. The moment you plug your computer on the network, you are the DHCP version 4 client. Now, don't let me say, let me rephrase. The moment you tell your computer to obtain IP address systematically and plug on the network, you have turned that computer to a DHCP client. And what the computer will do immediately is to send what we call a DHCP discover message or broadcast. DHCP discover message is a broadcast, and we have discussed broadcast in this class. Broadcast is, I am looking for a DHCP server. If you are the one, please send me if you are the DHCP server, I need an IP address. You can see the message. It's a broadcast. It will be sent to everybody on the network. I would like to request an IP address. So the DHCP server, if you have one, is going to reply with DHCP offer. And that message is a unicast. It is okay. I am the DHCP server. Here is an address for you. Then the computer will reply with DHCP request, which is also a broadcast again, and say, I accept the IP version 4 address offer. And then the server will reply with DHCP acknowledgement, which is also a unicast. Your acceptance is acknowledged. That is when a computer gets an IP address. Before any system will get any IP address, these stages must be completed. DHCP discover message, DHCP offer message, DHCP request message, DHCP acknowledge message. All these stages must be completed before you can get an IP address on the network. So this is what goes on behind the scene. We're just telling you what goes on behind the scene. When you plug computer on the network and you're looking for an IP address, these are the stages. And if you run Wireshark, you will see Wireshark will capture all of this for you. So what if you want to renew? Why would you want to renew? Your lease has expired. What do? You send a DHCP request message to your server. I would like to renew my lease. Then the server reply with DHCP acknowledge. Your request is acknowledged. That is when your time or your timer has expired and you want to have another IP address or want to keep that one that you have. You send a DHCP request, and that is also a unicast. So I want to go to the configuration now and let's see what we can grab here. I hope my explanation is clear to you guys. Please, I need you to talk to me. Yes, Ali, can you ask the question?
If you can go back to the slides I saw that when the DHCP client sends a request, it is again a broadcast request. Once it has received a response from the server, why is it sending a broadcast request again? Why is it sending a unicast here?
I was waiting for you guys to ask me that question. That doesn't make sense to me either, but that is the way they designed the protocol. Because
Okay.
now that the server has a reply, it should be able to return the reply to the server with a unicast message. So this doesn't make sense to me. You have a point here. Yes, please, Mr. Samuel, go ahead. Add something to you.
Yes, the mechanism is designed this way because from what I read, it assumed that you might have more than
More
one
than one
DHCP
DHCP
server
server.
on the network. So when the client is replying to the server that provides its IP address, is also sending a message to other servers that he has gotten an IP address. So he doesn't need their service again. And that's why it's broadcast. So that every DHCP server
Okay,
on the
I get
network
your point. I
gets
get
it.
your point. Ali, do you agree with that? Yeah, thank you, Mr. Samuel. I've never read that, but for me, it doesn't make sense to me. But now it makes sense to me. I think I've heard that it can send to more. It sends because you may have more than one DCP server on the network. But why do you still need to reply with broadcast? Because it's only one guy that is giving you IP address. So let's check it. Let's build a LAN with two computers. And let's decide, let's use 200.100.100.0/74 as our network address for this LAN. And let's link the systems together. Now, these computers that I have on the network here, they are going to pick IP address from 200.100.100.0/24 network. So I can give them maybe .2 and .3 because I always want to reserve the first for my router. Or let's give them .3 and .4. I will show you why now. We want to give these computers .3 and .4. We're keeping .1 for the router, which is going to be a DHCP server later. I'm keeping .2 for another server, which is just our dedicated server. Now, I don't want to give these computers IP address statically. What do I want to do? I want to bring in a dedicated server. We have a dedicated server in Packet Tracer. So I'll go and look for server here. This is a server here. I'll plug my server to the network also. So this server is part of this network. And the main job of this server is to dish out IP addresses. So now, what do I need to do? I will go and give this server IP address. Take note, servers are not given IP addresses dynamically. It has to be static. Now, let me explain that to you again. When I say it has to be static, sometimes when the router gives us IP addresses, you can tell the router, make that IP address static for that particular computer. So in a way, in a sense, we are not giving the computer the server manually, but it has been given dynamically, but we have told the router, don't ever give that IP address to anybody, only that server. So that address will now start functioning as if it's static. But in Packet Tracer, we can't do that. We have to do everything. Is that dynamic or we're doing static? So for this server right now that I brought out, I will give this server .2 of our 200.100.100.0 network. So I'll go to this place, go to desktop. We know how to do this one. Go to IP configuration. I want to give this server .2, 200.100.100.2 subnet mask. Then gateway 200 100.100.1. We don't have a gateway now, but we are going to bring in a gateway later. So our DNS, let's say 4.2.2.2 for DNS. So let's be sure that this server has accepted this IP address. Okay, so you got the IP address. Well, good. Now, this particular server has been given IP address manually or statically because it's a server. Now, I want this server to also do DHCP service for me, or to also be a DHCP server. This server can do so many things. Let me show you all the things it can do. If I click this place and go to services, you can see all the things this server can do. It can do HTTP, it can do DHCP, it can do TFTP, it can do DNS, it can do syslog, it can do triple, it can do NTP, it can do so many things. But what we want right now is just DHCP. So I'll click DHCP and it is off. I will on it. Now this server is just something to simulate, to help us simulate the real dedicated server in the world. Is to simulate. It's not a real dedicated server. In the real world, you use Linux machine or Microsoft server to set up a dedicated machine, a dedicated server. And when we say dedicated DHCP server, what we are simply trying to tell you is it's not doing anything apart from doing DHCP. That's the only thing it does. So I will run the service. Then next is full name. What do you mean by full name? The name of the addresses is like we want a name to qualify all the addresses. So let's call this one testing, or let's say CCNA. Then gateway, we don't have any yet. We are going to have later. So we'll say 200.100.100.1. DNS server, we want to put 4.2.2.2. What are we trying to do here? Look at what the next option I have. Start IP address. Because I want this guy to be a DHCP server, I have to tell it where it will start dishing the addresses out from. It has picked the main network address here as 200.100.100.0. But I can say I want you to start dishing out IP addresses from .10. And of course, you can see the subnet mask. So if I OK this thing now, if I save and OK, what will this machine do? We've activated DHCP service. We have given the pool a name. We have told this server about default gateway. And we have also told this server about DNS address. And we told this server start dishing out IP addresses from .10, 200.100.100.10 upward. If I save right now and go to the other computer, this server will begin to dish out IP addresses. It has become a DHCP server, and this is a dedicated. So let me save and see. Server pool cannot be modified. Okay, that means I have to add. Yeah, it has been saved. Why did he complain then? I can't remember. Okay, I can add. Okay, it has been added. So right now, this one is GUI, no command. I'll just go to my computer and tell the guy, now there's a server on the network. Go and get IP address automatically. So I'll select DHCP. Something is wrong here. You're not supposed to get .1. Let me go back to the server. It's supposed to be from .10 upward. Where is it? Let me remove this and do it again. So I don't want to change the pool name. Let's maintain that pool name and save it. You just override the one we have in that place. So let me save. It will override the one we have there. So I'm saying, okay, this is my default gateway. My pool name is server pool. DNN is 4.2.2. Start IP address where it will start dishing out from is from .10. So let me go back to that system and bounce it. Meaning, go to static and then come back to that side. You see that this guy got 200.100.100.10. It also got subnet mask 255.255.255.0. It got a default gateway 200.100.100.1, and it also got a DNS server address. And if you go to command prompt also, you verify that from command prompt. You can see the details here. If you want to see the DNS address, you say /all. Look at it here. Look at our DNS here. We did not go to this computer and give it IP address statically. Let's go to the other computer and say, you too, go and look for a DHCP server and get your IP address. I'll select DHCP. It says requesting IP address. You can see now DHCP request successful. And the guy has gotten what? Go to command prompt, IP config space /all. You see that the guy has gotten all his IP details. The guy was given 200.100.100.11 subnet mask. Was also informed about default gateway. It even got the IP address of the DHCP server, which is our server. That is this dedicated server. And of course, the DNS server address. So if you like, bring 10 computers to the network, 20, 30, 40, 50, 60, as soon as you plug to the network, because those computers are configured by default to obtain IP address automatically. They just get the IP details. So you don't have to crack your brain, helping people out, giving them IP addresses and all of that. They just get IP details. When I say IP details, all the IP information, IP address, subnet mask, default gateway, DNS address, they get all those details automatically. Why? Because there is a DHCP server on the network that has been configured to issue out IP addresses automatically. So now this is another computer right now. I'll go to this computer now and tell you to obtain IP address automatically. But in your computer, this is already selected. Obtain IP address automatically. And this guy got the 12. If I bring another one, you see, that is how these computers will keep on getting IP addresses without them being configured with IP details manually. Exactly. Talk to me, please. Yes. Okay, good. So now I want to yank off these things. I'm bringing a router. So what we have now is a dedicated server. Dedicated server. Meaning it is only doing DHCP. It's not doing any other thing, only the job of DHCP. But if we bring in our router now, the router will be doing VLAN, it will be doing inter-VLAN routing, it will be doing other things and also be doing DHCP. That means that our router is not a dedicated DHCP server. So you need to be able to differentiate between the two. So now, I can just go to this DHCP server of the service, and that's all. I've turned off DHCP. That server can be any other thing. It can be any other server. And if I like, I can yank it off of my network completely. So people don't get confused. I can just remove it from my network. So I can bring in a Cisco router and configure it as a DHCP server. How do we do that? Bring in a router, connect it to the network, to the switch, use any port of your choice. Then give that port an IP address from the network it belongs to. So I can give 200.100.100.1. Remember, we have been keeping that for the router. I'll say no short. That's all we need to do on this router. for basic connectivity. So now there's no DHCP again. These guys that got IP addresses before, if it's on a normal network, they are going to have problem now because no DHCP server. We'll be called the DHCP server. It will tell you all this thing that is showing now. It will tell you, it will show you 169. I'm going to talk about 169. You see 169 dot something dot something. Whenever you see 169, it simply means the computer auto-generated an IP address for itself. Why? Because it couldn't find a DHCP server. And that IP address can never browse the internet. But because this is Packet Tracer, that's why you still seeing them. If I go back now and bounce this thing now, you're going to see that this is not going to work. If I go to static and go back to DHCP, because you don't have a DHCP server now, it's not going to work. Did you see what it's showing me? See the IP address it gave itself. 169 dot anything dot anything dot anything. Anytime you tell your computer to pick an IP address from the server and it's picking 169, just know that that computer is not seeing your DHCP server. See that the DHCP server is down, or it's available, or it's not reachable. Maybe the network cable to the DHCP server is bad, or the port on the DHCP, anything could have happened, but their computer is not seeing the DHCP server. And sometimes it's a software problem on the computer itself. So you see now, this guy doesn't have IP address. If I go to the other guy too, the same thing will happen to the other guy. Because we yank off the server. You see? So I'm doing this so that when we bring in a router, you see that this thing is going to work. Or when we finish configuring the router. So the DHCP has failed now because there's no DHCP server on the network. So we have a router and we have configured that router with an IP address. Let's go and configure DHCP on our router. Very simple and straightforward. The first thing you should do is from this, go to global configuration mode and say IP DHCP excluded address. IP DHCP excluded address. Why do you need to do this? Sometimes you have some IP addresses you want to use for servers on the network statically. You don't want the router to give them out to computers because you have decided to use those IP addresses manually. So you have to exclude. So let's say 200.100.100.1 spacebar 200.100.100.10. What am I telling my router? I don't want you to give anything from .1 to .10 to anybody. Why? They are used. I want to make use of them. So you can start dishing out IP addresses from .11. That is the first thing you should do. Then the next thing is now to configure the DHCP service itself. And we'll do that with a command, unlike the other time. IP DHCP pool. You name the pool. Let's say CCNA. Hit enter. IP DHCP pool. Now, sometimes you have LAN A, LAN B, LAN C, LAN D. You name those pool based on the LAN that they will serve. Like when we did our VLAN, I was actually looking for our VLAN topology so that I can use it for this lab, but I couldn't locate our VLAN topology. So you create different pools for different subnets and give them name based on their subnet. If I put question mark now, the commands I need to issue in this place, they are not much. It's just default router, which points to tell this router about the default the IP address on the router to tell the people, that is the computers on the network. DNS server address. I'm going to also tell this router, tell people about these DNS IP addresses because they need to know about their DNS server. Domain name. What is the domain name of this environment? Then the network. What is the range of the addresses? As in which network are we dealing with? So I always like to start with network first. As I say, network 200.100.100.0. Then I think it's net mask. Okay, I'll just put the subnet mask 255.255.255.0. So what am I telling my router here? This is the network address. And this is the default gateway, say default router. The moment you put these two commands, the router has started dishing out IP addresses. But there are other things we want this router to also dish out. We want the router to also tell the computers about DNS server, which is 4.2.2.2. We also want this router to tell people about the domain name of this environment. Let's say unijos.edu.ng. So all this information will be given to computers. The router will give you your IP address. It will give you your subnet mask. It will tell you about default gateway. It will tell you about DNS server, and it will tell you about the domain name. And of course, it's going to exclude the IP addresses we told you to exclude. And guess what? We're done. How many commands? We excluded IP addresses first. We created a pool, and inside the pool, we defined the network, which is subnet mask. We pointed to the default router address, which is our gateway. We pointed to the DNS server address. We also put the domain name. So let's now go to our computers and tell them, guys, there's good news. There's a DHCP server on the network right now. So let's go and bounce their network. This guy has gotten .13 already. You can see, guys, can you see that? So let's go to command prompt. IP config/hub. This guy got 200.100.100.13. He got 255.255.200 as subnet mask. Default gateway is 200.100.100.1. And also, the guy that is the default gateway happens to also be the DHCP server. The guy also got DNS address, and it was also told about the domain name, like universal environments or a company's, the website of the company, something like that. So all these details were given to these computers from their router. Let's go to other computers. This one has gotten .12, got subnet mask, got default gateway, and also knows about the domain name. Let's go to the last one. IP config. This one got .11. Subnet mask. Why didn't you get default gateway? What's going on? No. Let me bounce this one. Okay, I think he got this. This one got these details when we first, before we put other information. So it should get it now. So you can see this guy got .11, subnet mask, default gateway, which is our router, DHCP server, DNS address, and of course, gets to know about the domain name. So who is dishing out IP addresses now? Our router. Is the router a dedicated DHCP server? Nope. Why? Because it's still doing other things. So that's the difference between a regular dedicated DHCP server or a dedicated DHCP server and a Cisco router that is also doing the job of DHCP. And this is good for small organization. If you have a campus network, don't even think about using your router as a DHCP server. You're going to run into trouble. Why? Because when your router builds, as your router continues to dish out IP addresses, is building a database, show IP DHCP binding, is building a database where it will tell you this person with this MAC address, I gave this person this .12. This person with this MAC address, I gave this person .13. This person with this MAC address, I gave .11. At the time this database is filled up, the router is going to have problems. We've had that issue on our network before. People were not just getting IP addresses again. Why? The router's database is crazy. And if you don't have enough RAM, They're going to get into trouble. So it's good to have a dedicated server, DHCP server, for a big network. And that's it. Any question? I like teaching DHCP. Any question? Do we understand? Good. Go talk to me, guys. So to set up a router for DHCP service, Cisco router, non-Cisco router, it's not a big deal at all. Anywhere in the world, any vendor, GUI or command line, you just need to understand how DHCP works, how DHCP operates, and that will be all. Thank you, guys. So let's finish the remaining story. Still have like 30 minutes to go. So configure a Cisco iOS DHCP version 4 server. We have done that already. Now that you have a basic understanding of how DHCP version 4 works and how it can make your job a bit easier, a Cisco router running DHCP iOS software can be configured to act as a DHCP server. That is what we just did now. The Cisco iOS DHCP server assigns and manages IPv4 addresses from specified address pools within the router to DHCP version 4 client. We did that. And look at what they have on their own network. They have a DHCP, a DNS server here. This router is a DHCP server for people on this segment. And if we like, we can also make this router DHCP server for people on the other segment also. Because this is 11.0 network and this is 10.0 network. If I like, I can have another segment here, create another DHCP for people on that segment. If I like, I can have another segment here, create another DHCP for people on that segment. And this router will take care of everyone. So all these steps, we've done these ones ourselves. So let me see if there's anything I left out. So you can see I excluded the range of addresses. You can exclude only one if you like. You can exclude range. You can pick in between and exclude. They define the pool, then point to the network, and this with the subnet mask, default router, the DNS server address, and then of course the domain name. And this is the topology they use here to do this configuration. So of course you can see the network they are pointing to here is 10.0, this place here. So they are using this router as a DHCP server for this segment. And it can also be used for the other segment if we want. It makes no difference. So how do you verify the configuration? Show running config, pipe section DHCP, show IP DHCP binding. I just show you guys that one now. Show IP DHCP server statistics. This one doesn't work on Packet Tracer. But let's check out this one and see the output that we're going to get. Show running config, pipe, section DHCP. So what will this command do? It will just bring out all the configuration that we did to bring them out for us from our running configuration file or from our RAM. It will bring out all of these stuff. So if your DHCP is not working and you are trying to troubleshoot, you won't probably want to see what you did. Maybe you made a mistake. Show running config pipe section DHCP will help you out to do troubleshooting. That is from our own router. Look at it here. They have it here too. The binding, look at it. It will map the MAC address to the IP address that you got or you gave out. And then show IP DHCP server statistics. These are all the things you're going to see, but this doesn't work on Packet Tracer. You see the memory usage, the address pool, automatic, the numbers of binding that have been done already, and the numbers of discover message that has been sent out or received. All of those details you're going to get from here. But this doesn't work on Packet Tracer. Of course, I've issued this command again and again and again. ipconfig/all. You can see the domain name, the IP address gotten, default gateway, and of course the DNS server address. This command is handy. One of my students went for interview. They said, how do you check the IP address of the computer, including the DNS address? He said ipconfig. They said, yes, they know ipconfig. But what if you want to see the DNS server address? He couldn't remember. So don't ever forget that. ipconfig/all. What if I don't want my router to do DHCP? I can turn it off. If I go to my router and say no service DHCP, I have just put off DHCP. And I want to off it on it back, I can say service DHCP. So what if you are trying to activate DHCP on a router and it's not working? Perhaps it has been disabled. You can re-enable it back with service DHCP. This is the last part. Let me be sure we're together before I go to the last part. Any question? Any question? Are we good? Okay, thank you. Thank you, Ali. Thank you, Mr. Samuel. Okay, got it. Sorry. So this is the last part, I believe, under this DHCP. That is for today's class. DHCP version 4 relay. Why do I need to relay DHCP? It doesn't make sense. I know Ali will ask me that question. But sometimes people do it. Let me get my blank page and explain some concepts. Let's assume you have an organization. This is the headquarters, HQ, and they have what we call BO. BO is branch office, another branch office, another branch office. So here there is a local area network, like banks. I always use bank. There are computers here. Local area network, there are computers here. Local area network, there are computers here. Even the headquarters too has its own lab, and there are computers here. And all these branches, they are connected to the headquarters. Why do they need to connect to the headquarters? That was then. Now, in the advent of cloud now, with cloud, people don't go to the headquarters again, or everybody goes to the cloud, including the people at the headquarters. Because back in those days, the server is always present at the headquarters. The application server they are using. So everybody have to go to the headquarters. But with cloud now, people are not going to the headquarters again, they go to the cloud. So what they do back in those days is they will configure this router to serve this LAN here. At the branch, let's call this one BO1. That is branch 1, branch 2, branch 3. They will configure this router again to serve people IP addresses in LAN, this branch 1 LAN. This router again will be configured to serve people here with IP addresses. The same router will be configured to serve people here IP addresses. So on the headquarter router is serving their own LAN and is serving remote LANs in different locations. That is the concept of DHCP relay. So what is going to happen? Here comes Ali. It's in branch 1. He plugs to the network. It's in need of an IP address. He sends a DHCP discover message. The DHCP message gets to the switch. The switch replicates it, forwards it to everybody. It gets to the router. But we know the router does not forward broadcast. It pushes it back. So what we want to do right now is this. We want to tell this router on this interface, if you get any message that has to do with DHCP, relay it to the headquarter router because it has a configuration meant for people on this LAN. That is the concept of DHCP relay. The same thing will happen on this network here. Here is Mr. Samuel. He's looking for an IP address in branch 2, maybe in Lagos. And probably this one is in maybe Port Harcourt or London for people that are not Nigerians, so that they understand. London, or let's say Dubai, but in a different, it will be in a different country. So the broadcast, DHCP broadcast will get to the router. We have to configure this interface and tell this interface, when you get the DHCP message, relay it to this headquarter router. The same thing applies to this guy. Anybody can come here, try to get an IP address. It goes to the headquarter router. So this creates a single point of failure. Why? If anything goes wrong with this link, you people cannot even work locally because your system will not get IP addresses. Anything else goes wrong with this link, you can't work locally. Anything goes wrong with this, you can't work locally. So it makes sense for every router to serve its own LAN. Serve your LAN as far as IP addressing is concerned. Be the DHCP for your own local area network. All other information, all other services can be gotten from the headquarters, no problem. This is what they were doing back in those days with DHCP relay. This explanation clear to you guys? Good.
Yes, sir.
Good. It doesn't make sense, but we'll have to explain the concept. It's still out there. Okay. So I think we have a topology I skipped. This is the topology here. So somebody here, this guy here, is looking for a DHCP server. He sends a broadcast. The broadcast gets to the router. The router says, but I don't forward broadcast between networks. Look at where the DHCP server is. It's on the other segment of the network. The DNS server is also on the other side of the network. How can we make this happen? We have to inform this router on this interface. When you do get a broadcast that has to do with DHCP, forward it to this DHCP server. In our case now, that my design is a what do you call it, a router, but in this case now it's a dedicated DHCP server. This is the concept of DHCP relay. So what's going to happen? We'll go to the interface of the router. Look at on that interface of our router, interface gigabit 0/0, and the command to get this, to do this magic, is IP EPAL address. IP EPAL address 192.168.100.11.6. Who is the owner of this IP address? It's our DHCP server. We're simply telling this router one, if you do get any message that has to do with DHCP, forward this to this IP address. Look at the IP address here. 11.68 is our DHCP server. If you get a DHCP request message, it's not only DHCP anyway, but the one we are in, our context now is DHCP. If you get any message that has to do with DHCP, forward this to this IP address. And this is what DHCP relay is all about. And if you show IP interface, then that interface, you see EPAL address here. It's like when I get any broadcast that I get, as far as it's DHCP and there's some other protocols so that can be forwarded by the router, it will just forward it to that IP address. But we must make sure that that IP address is reachable. And we must make sure that the configuration to take care of that LAN has been configured on that server. If it is not configured on that server, nothing will happen. If that server is not configured to take care of that LAN, nothing will happen. So these are other services that can be relayed. Port 37, time protocol, port 49, TACAS, DNS, port 67 and 68. These are the ones we need for our DHCP. Port 69, TFTP, port 137 and 138 NetBIOS. All of these can be relayed by the router. So anytime you see us configure IP level address, all of these protocols can fit into that. They are called UDP services. But our concern here is DHCP clients, DHCP server issue, and it will go. So the concept of DHCP relay is if you don't have, I said that's the last thing, that's not the last thing, one more thing, sorry. If you don't have your DHCP server locally, your router must be configured to be able to relay the message to the DHCP server wherever it is in the world. It doesn't matter where it is. There is this agency in Nigeria. I was to go and work for them on their network to help them do something. I realized that this is what they did on nationwide. And they're trying to separate the configuration so that every router will serve their own LAN. I say now they have common sense. Why will you make one router to be the DHCP server for almost 200 locations? Or dedicated server precisely for almost 200 locations. So if there's no network on your at the headquarters, the rest are done. Because they can't even do anything locally. Because there will be no IP address on the system. So that's the concept of DHCP relay. Any question on that? I have one video where I demonstrated that. I put another router remotely, but the thing stressed me because it refused to work until I restarted the packet tracer. No, I restarted the routers and it started working. And then after I finished displaying, I wanted to show it in another class. I launched the thing. I did configuration. It refused to work, but because I had the experience before, I restarted the router and it started working. So I don't want to go into that in our class. I just want to explain the concept. Is that clear to us? Thank you. So one more thing, and we will be done. Sometimes you want to configure your router as a DHCP client. Why would you want to configure your router as a DHCP client? Sometimes you have connection from ISP. This is ISP's router. This is the router in your own house that connects to your switch. Then there are computers here, and you can also have wireless or whatever you want to. Now, this connection between your router and the ISP on this interface, they may not give you static IP address to put there. They may just tell you configure that interface to connect, to obtain IP address automatically. What that means is they will configure this ISP router as a DHCP server. So when you connect, they will automatically dish out IP address for your router. If there's another client somewhere also, they know what to do. So how do we make the interface of our router to pick IP address automatically from somewhere? Let's check it. Configure a DHCP version 4 client. Look at the scenario here. This is Soho router, small office, home office. This is our DHCP server that is from our ISP. They have what they call a cable modem or DSL modem. That is what is bringing the internet connection. So this interface is connected to the cable modem. So the connection from this router goes through the cable modem. But we need to configure this interface to pick IP address from our service provider. What is the command? It's just to enter that interface and say IP address DHCP. Normally before, when you want to put IP address on the router, you say IP address, then you put the IP address. But now you don't do that. You just go to the interface and say IP address DHCP, and you say no shutdown, and the guy will go to the DHCP server. It will send DHCP discover message and go and look for IP address. And by the time he's done getting IP address, you're going to see it's going to show you that address. He's got the address through DHCP. You can see all the information going up here. Assign DHCP address. Then it shows us the IP address that it has gotten and the subnet mask and the host name of the device that got the address. So this is only for routers that are connected to the service provider. Sometimes we also have what we call home router. These are small routers. I think we have it on Packet Tracer too. You can also configure that interface to obtain IP address automatically from your DHCP server. These are small routers. I will show you guys now. Let me show you on Packet Tracer. So that one is not by command, it's just GUI. I'll go to wireless now. See the router. This should be the router. This should be the router. I'm still going to show you how to configure this basic wireless network. It's in the video that I will be sending to you on weekend. So I can go to the GUI here. Look at this router. These are small routers that connect to the internet. They are GUI. So I can go to this interface that connects to the internet and say automatic configuration. But if I don't want automatic configuration, I can just click this and say static IP. And I'll put all the IP address that my service provider gave to me. The IP address, the subnet mask, gateway, DNS, all the IP details that I got from my service provider, I will put here. But in case your service provider said nope, just configure that interface as a DHCP client. You come down here and you select automatic configuration. And that is on the one link. That is on the interface that connects to the service provider, just like what I just showed you here. Just like what I showed you here. So let's say this is this router. They are called, what's that now? Small office or home router or something like that. I forgot the name. So it's just a small router. Let's say it is connected to your service provider. So that configuration you are doing, even though it's GUI, is on the interface. And this interface is connected to another router somewhere. So because this is a small router, it's not command-based, you just go to inside, you go inside the router and tell that interface to do automatic DHCP configuration. And it's going to get IP address from the service provider. And then people on the network can now browse through that router. So whether it is GUI or command line, you should be able to configure your router as a DHCP client. Even this router also can do DHCP service to people on the LAN. See this part? Let me show you this part. You can see DHCP down here. DHCP server, enable. I can disable it. I can enable it. This is to serve people on the local area network. That is why most of these small routers, when you just plug them wirelessly, they start giving people IP addresses, because by default they are configured as DHCP server. If you plug to them, they still give you IP details because they are configured as DHCP server to serve your local area network. They are business router, they call it. Small business router. I think it's small business router, they call it. They are not like the regular big routers that we've been working with since we started this class. So, and that is it about DHCP clients. So you can do command line and you can also do GUI, depending on the type of router you are working with. Any question? Are we good?
Yes, thank you very much, sir. I think
Yeah.
the